Hi everyone, this is Siddharth Nayak, and today we will be discussing one of the most important topics in the field of operations research, that is called the Big M method. Now we know that while solving LPP, there are several methods that we can use, and one of the most conventionally used method is the graphical method. But there are several limitations to graphical method, which is that when the basic variables are more than two, we can't use them. So we have to resort to other methods like simplex method, two-phase method, or the Big M method. Now, the Big M method can be called as an extension of simplex method because in simplex method, as we know, we use two extra variables other than the basic variable called the slack and the surplus variable. And in the similar way, we use another extra variable along with the slack and surplus variable in the Big M method that is called the artificial variable, which is usually represented by the letter A. Now, to understand this topic, I will be just giving an overview regarding this method, and then I will also be explaining an already solved example, hoping that you will understand it very clearly. So let's get started. So the Big M method is a method of solving linear programming problems, as we know. So one of the major things that we must understand here is that in simplex method, there are slack and surplus variable whose coefficient is zero. But in case of artificial variable, which we are going to be using in the Big M method, their coefficient is represented by using letter M, which can be considered as a large number associated with the artificial variables. So let's see the steps in solving the Big M method. uh, we must understand that we only add the artificial variable when the constraint is greater than equal to or just the equal to type. We do not add the artificial variable when it is of less than type. We then just use the surplus variable. So the slack variable. Now, important point to remember is uh, we will use the simplex method when when these three cases arise: if no artificial variable appears in the basis and the optimality conditions are satisfied, if at least one variable in the and one at least one artificial variable in the basis at zero level and the optimality condition is satisfied, if at least one artificial variable appears in the basis at positive level and the optimality condition is satisfied, then the original problem has no feasible solution. So this was just an overview regarding the topic. You will understand it more clearly when I will be explaining a very nice example that has been curated specifically to understand this topic. So yeah, here's the question which we have at hand. Here, the question says that we have to minimize the objective function 12x1 plus 20x2 subject to constraint 6x1 plus 8x2 greater than equals to 100, 7x1 plus 12x2 greater than equals to 120, where x1 and x2 is greater than 0. So the first task which we have to do is converting this equation to standard form. Before writing the objective function, let's just convert the constraints into equalities. Now, since we can see that both the constraints are greater than equals to, in both these constraints, artificial variable will be used. Which is one of the purposes why I chose this example, because in there are examples where the constraints are less than equals to and there are no artificial variable used, but that will not be helping in understanding its use. So yeah, here we have subtracted the surplus variable and then added the artificial variable in both these cases, and we also have added the surplus variable in the objective function and the artificial variables in the objective function. Now we can see here what I was talking about, that the coefficient of the artificial variable is represented by m, and consider m as a very large number. And This assumption is important because while doing the iteration table, it will be of a much more significance. You will understand that later. Now let's build the initial table here. So since both the constraints have artificial variables, we will consider the basic variable as a1 and a2 in the initial table. So in this table, CB shows the basic cost of the basic variables a1 and a2. CJ shows the coefficients of the objective function. Here the CJ will be shown, x1's cost is 12, x2's cost is 20, s1 and s2's cost is 0, 0 respectively. A1 and a2's cost is. Now the values here represent the cost of the basic variables in the constraints. Here x1's value is 6 and 7, 8, 12, and so on. Now, first, our job is to find the zj values, which is the product of these two values, respectively, these two, and their sum. And we will follow the process for all the basic variables. Let's see here 6m plus 7m, that is 13m, 8m plus 12m, 20m. And in the similar fashion, we will find all the values. And then we will find Cj minus Zj. And we can see that it becomes 12 minus 13m, 12 minus 13m, 20 minus 20m, and so on. Now we can see that not all the Cj minus Zj values is not greater than 0, greater than or equals to 0. And we also now know that for the iteration to end, it is a necessary condition that Cj minus Zj has to be greater than or equal to 0. Otherwise, the iteration will not stop in the case of minimization functions. Now, so we have to find the key row, key column, and the key element. Now, in this case, the key column will be this one, because as we can clearly see, 20 minus 20m is the smallest value among all of them. And that's where the value of m comes into consideration. I had talked earlier about how m is a very large number. So 20 minus 20m becomes an even negative becomes the most negative number among all of them. So this becomes the key column. Now we will find the ratios, that is b upon the value of x2's, and we will get it as 12.5 and 10. So, and here we will take the smaller ratio, that is 10. So the number coinciding the key column and key row is 12, which comes under x2. Therefore, in next iteration, we will replace the basic variable a2 by x2. Also, in the another major aspect of this big M method, which makes it different from simplex method, is that when the variable gets replaced, that variable is removed from the table itself. We can see that in the next table, a2 is missing. The column of a2 is missing, but that doesn't happen in simplex method, where the surplus or the slack variables is not removed. So yeah, here we can see that the row transformations which we have applied, our aim is to make this element 1 and the element above it 0. So we have divided the row R2 by 12 and then subtracted the row R1 multiplied by the new R2. So after performing this row transformation, we will get our first iteration. So again, we will follow a similar method which I had talked about earlier. And again, we can see that the value of Cj minus Zj is not completely positive. We still have negative values. Now we will find which is the most negative value here, which is minus 4m by 3 plus 1 by 3. So x1 becomes the key column. Now we will find the ratios again, and we can see that 15 is the smaller value. Therefore, 4 by 3 is the key element. Now we can see that x1 will replace a1 artificial variable. Therefore, the column of a1 will be cancelled. Therefore, we can see that in the next iteration, both a1 and a2 gets removed. The basic variable has become x1 and x2. And we can also find that if we follow the similar steps, cj minus zj are all positive or equal to 0, which is exactly the condition that we require for our iteration to stop. Therefore, we can stop our iteration and we can conclude that the values of x1 and x2 is 12 and 20 respectively, where the values, its basic cost is of course 15 and 5 by 4. Therefore, the minimum value of the objective function is 205. And since b value of b is 15 and 5 by 4, we can see that x1's value is 15 and x2's value is 5 by 4. These are the values which we require for minimizing the objective function z, and the surplus slack and the artificial variables is 0. Hope you understand this example. Uh, it's a bit tricky topic, but it's not very hard. If you practice it regularly, you will understand that easily. Now let's see another example of maximization. Now, since we have already seen minimization, we don't have to delve into it completely or very deeply. We will just see an overview. So here we have the question: maximize z is equals to x1 plus 5x2, subject to constraints 3x1 plus 4x2 less than equal to 6, x1 plus 3x2 greater than equals to 2. Now see, here we have a constraint which is of less than type. So we can see that we won't be needing to add the artificial variable in that constraint. We will just be adding the artificial variable in the second constraint, which is of greater than equals to type. There can be a slight confusion here because in the other question we had represented the slack and surplus variable using x1 and s2, but here they have represented it using x3 and x4. But there's no need for any confusion. It's just a way of representation. You can represent it in any way you want. So yeah, we have written the standard form here. This is the first table. You can see that the condition to satisfy the iteration is not yet satisfied here. So we will perform more iterations. We can see that in this case, we only had to perform one iteration. Now, another thing which we have to notice here is that we in our question have used say cj minus zj, whereas they have used zj minus cj. So our condition was that we need all the values of cj minus zj to be positive or equals to 0. Now, if they have considered zj minus cj, the condition will become that the value has to be less than or equal to 0. But there's no need for any confusion. It's just the way they have represented it, and we just need to take care what's the condition we have to follow. Otherwise, all the steps are similar. So hopefully, you have understood the Big M method correctly. Uh, it is a very simple method because if you already know simplex method, if you have grasped the simplex method, it is not much different from the simplex method. Big M method is just an extension of simplex method, like I had talked before. But we really need to be aware of what we are doing while solving the question, because iterations can be overwhelming sometimes. So we need to be really aware of what the numbers which we are writing, because in this case we will be using another variable called m and all. The solution contains m, so there is a chance of getting confused, but we just need to remember that m is a very large number and solve further. Also, make sure that you are checking the equations and the tables correctly before proceeding further. And also use a logical approach, because by logical approach, you can see that if your answer is wrong or not. So yeah, thank you. You may post any doubts in the comment section. I will be considering them surely. Thank you.